Hello everyone, welcome back to AA STEAM series. This is electricity part 4. In the last video, we talked about voltage, current, AC, DC, series versus parallel, and the parts of a circuit diagram. Today, I'll teach you formulas on how to find power, energy, and what Ohm's law is. I'll also be walking you through some sample problems, so feel free to pause and try to work them out on your own before you see me solve it. Let's get right into this video. This is Ohm's law. It describes the relationship between voltage, current, and resistance in a circuit. V is volts, I is amps, and resistance is measured in ohms. These are the variations of the Ohm's law formula. So, we have a sample question right here. A load has 1.2 amps of current flowing through it. The resistance of the light bulb is 5 ohms. Calculate the voltage of the battery. All we need to do here is that we know that I equals 1.2 amps. The resistance is equal to 5 ohms. And we need to figure out voltage. So all we do is write in the formula, voltage equals I times R, plug in the values, voltage equals 1.2 amps times 5 ohms, and you calculate it, voltage would equal 6 volts. You write therefore statement, therefore the battery is 6 volts. There we go, not so hard. Next, this one is slightly harder. So before, we used directly Ohm's law. We didn't have to change it in any way. But in this, we're trying to find current. So that means we're going to have to change the formula around a little bit. So we're trying to find current. So I is equal to question mark. We have volts, which is 3 volts. And we have resistance, which is 1.5 ohms, and we have the base formula. V equals I times R. Now, as you can see, we are trying to find current and not voltage. So let's rewrite this up here. Voltage is equal to I times R. So since we're trying to find current, we divide everything by resistance. We divide this by resistance, we divide this by resistance. Since it's an equal sign, it means both sides need to be equal. So you divide both sides by resistance. These two then would cancel out, and that would leave us with V over R equals I. So now we just tweak the formula so we can find current. Now all we need to do is plug in the values. 3 volts divided by 1.5 ohms equals 2 amps. There, that wasn't that hard. So now we have to write, therefore, the current is 2 amps. There we go. Now we'll be talking about power. Power is measured in watts or kilowatts. 1 kilowatt is equal to 1000 watts. Electrical power measures the rate at which electrical energy is being used. Power depends on both the energy of the electrons, voltage, and the rate at which the electrons are flowing, the current. Power is the rate of doing work. So power equals V times I. So I have a little sample question here to get the gist of it. A toaster operates a voltage of 120 volts and draws a current of 5 amps. How much power does a toaster use? So all we need to do is take these values. So we have potential difference is 120 volts, current is equal to 5 amps, and we have the formula power equals potential difference times current. All we need to do is plug in the values. So power equals 120 volts times 5 amps, which is equal to 600 watts. Power equals 600 watts. There we go. Now all you need to do is write a therefore statement. Therefore, the toaster uses 600 watts. There we go. Now you want to put a box around your answer so it's always easy to see. This next question is going to be slightly more challenging. A 60 watt light bulb is connected to a 120 watt power source. What is the current flowing through the light bulb? And then the second step is what is the resistance of the light bulb. So there's two things we need to find out. Right now we have the power, which is equal to 60 watts. We have potential difference or voltage, which is equal to 120 volts. We need to figure out current, which is I, and we need to figure out resistance. First, let's start with current. So we have the base formula of power equals V times I, and since we're trying to find I, we divide everything by V. Oops. Okay, let's just say we divide everything by V. So you get power divided by V, these would cancel out, equals I. There we go. Now we plug in the values. So 60 watts divided by 120 volts equals 0.5 amps. So we have figured out current now. So write I equals 0.5 amps. Now we need to figure out resistance. For this, we'll be using Ohm's law. So write V equals I times R. And since we're not trying to find V, we're trying to find R, we divide everything by I. These two would cancel out, and you get the formula V divided by I equals R. There we go. Now all we need to do is plug in the values. So 120 volts divided by 0.5 amps equals 240 ohms. There we go. So we write, therefore, blah blah blah, the resistance of the light bulb is 240 ohms and the current of the light bulb is 0.5 amps. That wasn't so hard, was it? Now I'll be talking about energy. Energy is the ability to do work. It's measured in joules or watt hours. There's joules is technically watt seconds, and watt hours is, well, watt hours. There's no such thing as watt minutes. In this formula, E represents energy, which is in joules, which is watt seconds, or watt hours. V, which is potential difference, I, which is current, and delta time, also known as change in time. It is just how long or what amount of time or how much change in time happens between the beginning of the process and the end. So in this sample question, we have how much energy in joules does a toaster use if it draws 2 amps on a 40-volt system, takes 30 seconds to toast the bread. So we have our I, we have our V, and we have our delta time. So we have I equals 2 amps, V, potential difference, equals 40 volts, and we have delta time, which is equal to 30 seconds. Now all we do is plug in the values. So E equals V times I times delta, the change in time. So energy equals 40 volts times 2 amps times 30 seconds, which is equal to 2,400 joules. We're at therefore statement. We're at therefore the toaster uses 2,400 joules. Right. Now this one seems a little tricky. So a 1,500 watt electric toaster is connected to a 240 volt outlet. What is the current drawn by the heater? What is the resistance of the heater? How much energy does the heater use in 3 hours in kilowatt hours? Whoa, that's quite a lot. All we need to do is break it down and take it step by step. So we have power, which is equal to 1,500 watts. We have potential difference, which is equal to 240 volts. We need current, we need resistance, and we need energy. We actually already have delta time too. It's saying how much does the heater use in 3 hours. We have delta time, which is equal to 3 hours. There we go. We'll first tackle current. So again, we would use the power formula. So P equals V times I. You would divide everything by V. You're trying to get I. These two would cancel out. P divided by V equals I, and be 15,000 divided by 240, which is equal to 6.25 amps. There we go. So we have I equals 6.25 amps. Next, let's tackle resistance. So for resistance, we will need to use Ohm's law, which is V equals I times R. We will divide everything by I, because we're trying to find resistance. These two would cancel out, and we'd be left with V times I equals R. So we'd have 240 volts divided by 6.25 amps is equal to 38.4 ohms. There we go. So we write resistance equals 38.4 ohms. Now let's find out energy. Right, energy formula, energy equals, actually, fun fact, you can use, instead of writing V times I times delta time, you can just do energy equals power times delta time. Do you realize why? I'll give you a second to think about it. Because the power formula is voltage times current. So instead of writing voltage times current, you can just write power. And we already have power. So all we need to do is energy equals 15,000 or 1,500. Oh, whoa, that's 15,000. That's a lot. 1,500 watts times 3 hours, which is equal to 45,000 watt hours. But now the question is asking us to get it in kilowatt hours. So all we need to do is times everything by 1,000. So this times 1,000 would mean energy equals 4.5 kilowatt hours. Whoa, that wasn't so hard now, was it? Now that we broke it down step by step, it was really easy. In the next video, I'll be talking about how to calculate efficiency and cost. Thank you so much for watching. Make sure to like and subscribe. I'll see you guys in the next one.